Guys, we've been looking at the polar situation, and I've talked about the cryospheric effect. And without the planet's cryosphere working, guys, everything's going to overheat. The system's going to slow down. The jet streams will break apart. Your ocean currents will slow down, break apart. And what that does is allow very chaotic weather to set over one area for a long period of time, whether it's a heat dome or whatever it is. Now, we're about to get into that, so don't go anywhere. And we're going to be looking at some things that are affecting the planet much faster than what the models are indicating. They're showing, if you look at either NOAA or the European models of how the ice melt is working, they're saying we're going to see some serious problems by 2030, 2035, possibly 2040. This is going to kind of smoke that real bad because I'm going to look at the data and not the models. Very important, because this is your planet. This is our planet, and it's in big trouble. We started looking at the Colorado River system. We saw all of the effects there, including the loss of the snow melt on the Rockies, especially the southern Rockies at above 14,000 feet. They became thermal radiators instead of being alpine cooling units. It's happening to the Himalayas. It's happening to both poles, many mountain areas. They're just, last year started this, guys. Let me back up just a moment. And we didn't see a very good winter as far as snow in the Rocky Mountains or anywhere on the planet. So when we got into March, it wasn't that much to melt, but it melted it, and now we're seeing a collapsing Colorado River system. But what we're seeing at the poles now, guys, I'm doing the numbers. I went through it today and got the newest data, and both poles are collapsing. What was a solid ice sheet now is becoming slush. And what we're dealing with, guys, is water that's much warmer than normal. Sea ice, you melt at 28.3 degrees, something like that, when normal freezing is 32. But what we're seeing is 36-degree temperatures in the Arctic waters, and most of that is being pushed 5 feet under. They can tell by the wave movement. 5 feet under the ice and miles inland under it. And what that does, and you can even see the wave height, is cracking that ice and making it easier to break up. And what we're seeing, guys, are these ice sheets at both poles. They're transitioning from solid, rigid, hard ice buffers into fluid, mobile slurries. Now, you've got warm waves passing under it, but in some areas coming out of Siberia, and that whole area is like a massive warm section of the ocean all of a sudden. But you're getting 6.6 to 7 foot swells there that are battering the top of the ice shelves. And because of the heat, it's going to take it a long time to start to cool down and bring back winter weather and the forming of ice, because normally it's much cooler there. So about September into August, the sun is at a different angle and the weather starts to cool off there, and it immediately starts to refreeze and all. But we're getting 38 degrees temperatures and some of those open holes in the ice sheet, guys, and it takes it a couple of 3 months to get all of that heat out of the ocean. It's drawing it in because the water's darker, remember, and heat absorbs. So it's going to take it 2 to 3 months to get that heat from the deeper parts of the water into the atmosphere and cool things off. What does that mean? Instead of starting to see some winter weather or winter temperatures going down in September, it could be December. And that's very important, because what that's going to do is the same thing that happened to the Rockies last year that's happening to Colorado River. Very light snow, and it could well end up being rain, just like we saw on the South Pole. Remember when they reported they had the 36-degree anomaly during Arctic winter a month or so ago? The scientists down there were saying that they weren't getting snow. The rain was coming down, but it was washing the top of the snow off, and they were getting barren rocks. And that very well could be exactly what we see coming up, because the El Nino, the superheated section, has got tentacles, and it goes all the way from the South Pole to the North Pole, and everybody in between is catching it. But guys, this is going to change how our planet works. Again, the planetary winter break is failing because the sheer volume of stored latent heat in the water prevents seasonal recovery, turning the oceans into a permanent global radiator. And when both the Arctic and the Antarctic fail to recover during the cold seasons, they act as a synchronized planetary force multiplier. The data that's been tracked shows that by November 26, the global system will experience 3 major mechanical and atmospheric shocks. This is what I've been warning you about. Now, what we're going to see is called the bipolar heat lock-in. In other words, normally the way the planet works, one pole is cool, one is hot. It kind of balances out along with the tops of all the high mountains. But by November 26th, now this is looking at 1.3 million square miles in 1 month. You don't have but about 3 or 4 months of that, and you've got pretty low ice. But by November 26th, the seasonal cycles of both poles will violently clash instead of balancing each other out. And in the Arctic, guys, the immense volume of summer heat absorbed by the open Siberian and Baffin Bay waters running up to 6.6 degrees above normal, that's sea surface temperature anomaly, will attempt to vent into space. This massive energy dump will cause the Arctic winter freeze to stall out heavily, leaving the northern ice pack incredibly thin, fragile, and delayed. On the Antarctic, they're calling it the hammer. Concurrently, Antarctica will be transitioning into summer melt season. Because its winter sea ice cushion is already severely fragmented and surrounded by that circumpolar ring of marine heat waves, guys. And you've seen it come down into Trinity Peninsula. We looked at that. We saw the heat anomalies. But again, Antarctica will be transitioning into its summer melt season but it's already doing it. Because its winter sea ice cushion is already severely fragmented and surrounded by that circumpolar ring of marine heat waves that goes all the way around the Antarctic continent. It says the land-based ice shelves will be completely unprotected against the upcoming summer swells. Our planet is getting very warm. It's losing its cryosphere, its heating capabilities. Not only do you have stalled wind patterns, stalled ocean currents, but it causes great drought, and it will cause great famine. And it's not like it hasn't already started, guys, because Europe is reporting now, I think about 25,000 to 30,000 people have died from heat-related causes. And let me say this before I go further into some of these details is, just as we talked about for the last few months about there's going to be probably a lot of people that move out of the desert when you lose hydropower and water. Just, it's simple survival. But now we're looking at a planetary scale, guys, and so how do you plan that? Sometimes you really can't, but it does not keep me from reporting what I'm seeing. We'll figure it out, but we've talked about this before also, that if there's a big change, it will not be by flood this time. It will be by heat. Just saying. Again, November, we're going to see the equator and the poles. They will flatten significantly. Both will be warming. In the jet stream, it will lock that into a highly exaggerated stationary omega loop pattern. Instead of predictable autumn transitions, mid-latitude regions like the U.S., Europe, and Asia will experience extreme stuck weather anomalies, such as prolonged unseasonal heat domes setting directly alongside sudden, localized atmospheric river deluges. We're seeing that now. Texas is flooded. You get further west, and guys, it's pretty dry. We're getting some rains in the area, and we're seeing a few flash floods up around Lake Powell, things like that, that will eventually help stall the record water dropping. But guys, that is a temporary, and it's not enough to do a lot other than give you a few extra days. Now, in November also, you got what's called the Ocean's Conveyor Belt Drag. November 2026 will mark a period of intense freshening and thermal layering in the world's oceans. We talked about AMOC before. The massive volume of fresh water drained from Greenland summer melt, guys, and they are also surrounded by very warm water, warm topside temperatures, and large waves crashing into it. They're right there at the Arctic. But again, this massive volume of fresh water drained from Greenland summer melt, combined with a lack of sea ice formation in the south, which normally rejects salt to form dense sinking water, will act as a brake on global currents. How does the Gulf cool off? You have the current of the Gulf Stream that comes up and dumps it out up into the northeast below Greenland, up into that area. And it's at record-breaking temperatures as it is. But the slowing of the AMOC, guys, in the north and the Antarctic bottom water in the south will begin to constrict ocean heat distribution. The oceans will trap more heat in the tropics, further fueling late-season marine heat waves and hyper-intense storms. We're already seeing these heat waves form in the Arctic, but guys, when you think about what we're saying here, the south will begin to constrict ocean heat distribution. The currents can't carry it. The jet streams cannot carry it, and there's no cooling effect. You're almost looking at game over unless you have a way, and the survivors will be something like we studied in ancient Turkey. During Kuyu, 22,000 people could live in one space underground, and when you're in a cave or something like that, guys, the temperature stays pretty mild both winter and summer. That's why animals habitate there. And of course you know that. But that will be the type of survival that's necessary. It won't be building a Vera because a long winter's coming. It will be because the surface is getting too hot. But the thing about that is the crops are not going to do good. The droughts are going to set up. The earth is becoming like the Anne Ryan book. The earth is shrugged. She called it Atlas Shrugged, same thing. And regardless of how you look at it, how you try to absorb the information, the end result is the same. What are we going to do about it? Right now, it's new information, and if you go to any of the scientific data without looking at the maps that I look at, the ocean temperatures, the currents under the ice, the waves above them, the way everything's too warm, if you don't do that, you're going to get this 20, 30, 35 timeline of when you're going to see the sea ice go into this unbalanced situation. They have projected it out because they can see slight changes going back the last 10 or 15, 20 years. But suddenly the Earth is changing much quicker than their predictions. And really, as much as they get paid, they should be on top of this, and I shouldn't be having to do it. But that is another story. But if this data is correct, again, by November, the planet's going to show that clear physical evidence that both of its primary cooling mechanisms have been structurally compromised at the exact same time. We saw that earlier this year. Record temps on both poles. Now, guys, I've got a magazine of this information, probably 30 pages of it, and I don't want to go there and make this so boring that it becomes a moot point. And so, but the data we're looking at today, guys, I went and double-checked it, looked at everything again to see what had changed over the last few days until this morning. So the information you're looking at is current by just a few hours. And so the albedo takeover and the heat pumps, that's what we're talking about. The albedo effect is ice reflects heat back up, stays cold, but when the ice melts and you got a much darker water surface, it absorbs the heat. So the physics, when you talk about 5.7 to 6.6 degrees Fahrenheit, sea surface temperature anomalies, we're talking about the Baffin Bay and the entire Siberian shelf. And guys, in some of those areas, they're getting much higher than 6-foot seas. You get out into the middle of the Siberian shelf where it should be ice, and some of the waves are up to 26 feet. You know what that's doing to the ice shelves themselves? But again, this is the Baffin Bay Siberian shelf. The oceans are now giant heat batteries. That's putting in this data. And so the fuel is, when you combine that, and guys, there's a huge cyclone, very low pressure at 938 millibars, acting as a mechanical heat pump, dragging 34.8 degrees Fahrenheit air over the Arctic core. The heating is now self-sustaining. The ice can no longer cool the system down. That's what we're talking about. And guys, and because the difference of the poles, one's hot while the other's cool, you get that large spinning jet stream because there's a difference. But when they flatten out together, or when you flatten out the temperature, the difference between the equator and the poles, that jet stream loses its speed and it breaks into chaotic, stagnant loops. The result is when these giant atmospheric loops stall, they lock high-pressure ridges over continents for months at a time. Not weeks, not days. This blocks regular rain systems, creating prolonged, severe continental droughts. And what does that cause? You got agricultural system failure. Famine is the direct, unyielding math of a broken jet stream sitting over the planet's primary food supplies. Global food stability relies entirely on predictable seasonal weather in major bread baskets like the U.S. Midwest and the European plains and the grain belts of China and Ukraine. When atmospheric blocks cause relentless, unseasonal heat waves or catastrophic flash flooding over these specific regions, we're seeing it here again, crop yields collapse. The planet cannot sustain its food infrastructure when its global air conditioning fails. What can I say? Like I said, we're seeing immediate effects, and the immediate reality of the broken polar air conditioner is a massive surge in heat-related mortality across the entire Northern Hemisphere. Europe underwater and heat, guys. Data centers like EuroMOMO and the World Health Organization, WHO, have just confirmed massive spikes in excess mortality, with more than 25,000 heat-related deaths documented across Europe from late June to July. Guys, that's what the time we just measured, losing 130 million square miles of Arctic sea ice. Same exact time period. Again, 25,000 heat-related deaths documented across Europe from the late June and July heat waves alone. In places like France, the heat wave arrived so early and with such intensity that medical centers and emergency infrastructure became heavily overwhelmed. And for 2 or 3 months now, we watched the heat dome here over the U.S. I've showed it to you that's locked in over the four corners, and it's spreading all the way to the East Coast now. And if you look at the current tropical system, tropical storm now, then you're seeing the pressure of that movement from west to east pushing down and tearing the top of the storm off, of the northern half of the tropical storm off, while the bottom side is heavily laden with rain. And they had predicted the tropical storm Bertha to get it to about 50 miles per hour and kind of skate along the coast and end up crossing somewhere around Houston. It's already up to 60 miles per hour. The good thing about it is the El Nino that's moving from west to east again is putting a lot of pressure. It's pushing it down towards the Gulf. And when that happens, it's stripping the top off of the hurricane. You can see it. The bottom half is real moist. The top half is pretty dry. Clouds are starting to wrap, but not yet. But again, it's at 60 miles per hour already instead of that 50. But here in North America, Again, the massive heat dome is setting stationary over the U.S., driven by those exact jet stream blocks that we've been tracking. Temperatures have shattered absolute records. Guys, we never thought we would see some of the things we're seeing now. But, you know, we always wanted to say, well, we'd love to know what's going on, and wouldn't it be something to see the Earth change or go to a different age? There's going to be some pain in this one. No way around it, and I'm not going to put out a 2030, 2035 report giving you hopium. You're looking at the data, looking at the facts. And again, I rechecked every temperature this morning before getting this together and being able to do it this late in the afternoon. And let's drop into a couple of these maps just a moment. We're looking Here, again, is the U.S., and we're going to go right up here to the physical North Pole. Now, look what's happening. Just off center, we've got a huge storm system that's covering very large area of the ice sheet, if not the entire part. And what's happening, let me back this out. This should be much larger, by the way. But right now, it is a heat vacuum. And again, we're seeing currents come up around Greenland, all of it being pushed into this top of the globe vacuum, tornado, hurricane, whatever you want to call it. But it's pulling warm air from much further south out of Russia, out of the U.S. And let's flip it over here. Here's Russia. Here's the big rivers. And the rivers are so warm, just like the Mississippi River is, that they are feeding very hot water into the edges of the ice sheet, and it's penetrating very deeply in there. Guys, and what's really concerning me is every time I come back to this map, this bluer area and this area just a month ago was mostly ice. And just, again, every time I get a chance to come over here and look at it, we're losing more and more. Again, 130 million square miles in a month. But what you're seeing is, in the green, very warm temperatures, way above normal. In the blue areas, the ice is melted. This is real time. It's not a model. It's either picking up the temperature of the ice in white, or it's picking up the temperature of the oceans. Now, we've got very high winds, and they're reading from buoys and other data that we're not just seeing 6 and 7 foot waves slamming the ice sheets here, but again, 5 foot deep under the ice sheets. Warm water is moving towards the center. Everything's being pulled in. Let me just pull around here again. This Russian area and the Siberian areas, guys, are very warm. And if we look at sea surface temperature anomalies, that means above average. Here's our center, but look, coming up out of the Russian rivers here, look at this temperature. We're looking at 6.6 degrees above normal. That's why the heat is going to remain, and we may not see any type of real cooling until November. Definitely not much ice formation, maybe just continued melting, because, again, when you remove the ice, it doesn't reflect. The blue water absorbs the heat. That warm water is being pushed under all of the ice. That has to dissipate into the atmosphere before the water can get cool enough at 28.3, I think it is, degrees salt water to reform ice. If when what little is reformed, because we got these warm currents now, it won't last long. We are looking at some very tough situations, guys. Again, down into the rivers of Russia, like I said, this is 12.9 degrees above average. See this right here, sea surface temperature anomalies. Almost 13 degrees above average. It's too warm, and all of this is being pulled by this storm from every corner around Greenland, all through the entire North American continent, guys, or the Northern Hemisphere. This vacuum is pulling heat right into the worst place it could be in. Now, I didn't want to get into too many details, and I didn't. I got 30 pages of that, and you don't want to hear them. But I think we covered enough to kind of let you know what we're talking about here. And again, I don't know how you make plans for this. I honestly don't know, other than what I was talking about, the Vera, somewhere where it's going to stay cool, because this planet's about to get warm. But guys, we're watching it. You watch it. Remember, our Father loves us. He loves you. We love you. And this is a major heads up, guys. We're going to keep an eye on it. We're keeping an eye on Meade. It's getting very low. We're watching many other places. But right now, we've got an entire planet that's about to go completely into a stalled mode with no cooling. Think about how unbearable some of the heat is today. Guys, we are right now at 117 heat index. It's 6:30 p.m. Central. But in the heat of the day, we were at 126 for a very long time. Again, heat index. That's incredibly warm, even for this time in July. And we're going to lose our winter cooling. Again, we're watching it, guys. You watch it. It's a heads up. Be safe.